Good afternoon, everyone. Hi. You're at Interactive Art Tech. That's your title of your workshop.
It is, huh? Okay.
Yeah, it is.
All right, I'll take it.
So Chris Wininger, right? Is that how you pronounce it?
Wininger, perfect.
Is a software engineer, electronic artist, and lover of the weird. He is one half of the two-person team that birthed the Fong Phone.
Yep.
A collaborator on interactive art exhibitions such as Call and Response, and the artist behind Every Picture Tells a Story. He dedicates weekends to Infinite Industries, supporting the Lexington arts community. Chris currently works at Sonotype, where he is passionate about open source and develops tools that enhance the security and quality of enterprise software. So you are on until 1, and then Chrissy will be back. So welcome, Chris. Thank you.
Alrighty, perfect. Alrighty, yeah, so as stated, I'm Chris. I'm Senior Software Engineer at Sonotype, and I'm also the lead developer at Infinite Industries. Some of the people around here may have heard of Infinite Industries. I know Matthew back there has. He also works on that with me. So if you haven't, though, check out infinite.industries. That's infinite.industries, no.com. We promote cultural events around the Lexington area, so you can go there and you can find out all kinds of information about things happening in the area, stuff like this conference, stuff like bands you might want to go see, or gallery openings, anything that's kind of cultural and promotes the arts and culture of Lexington. I've been a software engineer for well over a decade now in some capacity or another, but I've also always had a lifelong interest in art. So that's something I've always been kind of tinkering with, and I don't know if the connection's always obvious to everybody, but for me, I think that some of the same things that drew me into computer science are the same things that attract me to art. And over the last few years, I've started kind of working on interactive art exhibits, and I've actually had the privilege of collaborating with some other people and getting to display some of those in galleries and stuff around town. So that's been a really fun experience, and it's been fun to kind of share some of that stuff and take it to a little bit of the next level. So I just kind of want to talk a little bit about that, about those experiences, some of the fun things you experience, like trying to do interactive art, and also just kind of go back to what got me into that and to why I find, trying to develop software as art to be such a magical thing, and why I think it can be such a powerful tool for the artist. So first off, what is art? That's a huge, loaded question that you can answer a lot of ways, but I like Frank Lloyd Wright's definition here. Art is a discovery and development of elementary principles of nature into beautiful forms suitable for human use. I don't think that's a perfect definition by any stretch. I think my definition would be much more broad than that, but what I really like here is this bit about discovery and development of elementary principles of nature, because I think that ties back to a lot of what we do as computer scientists and what you study in computer science, and really kind of gets at the heart of why I think they are actually so related and go so well together. So a favorite professor of mine, the late Jonathan W. Mills, once said, "Computer scientists are all failed biologists." So, well, what's that have to do with art? Well, or biology for that matter? Computers can be used to simulate processes that are found in nature. A lot of hardware components and algorithms also draw inspiration from nature. Computers can also exhibit behaviors that sometimes surprise us. They can sort of trick us into thinking they have an entity. So I think a lot of that is what drew me to computer science. And also it can allow us to visualize and interact with the everyday in new ways. It can draw attention to these forms found in nature. So I think coming back to that definition of art, I think that it's sort of inherently useful to the artist for those reasons, that you can use it to express yourself in different ways. You can use it to reframe the world you're looking at, whether that's reframing data in a new way to draw something out of that data, or whether it's reprocessing images around you, all sorts of ways in which you can use it for that sort of purpose. Another interesting thing about software, though, as a medium for artistic expression is that it often responds to the viewer as it's viewed, which is something that I don't know of any other medium that does. And that was something that, as a child when I first kind of experienced computers, that just blew my mind, and I just thought was pure wizardry, and I think like a lot of us, I sort of first experienced it through video games, and up until that point in time, the screen was this passive medium that talks to you. You never talk back to the screen, at least not in any way where it responds, but suddenly here was this screen that you could have a dialogue with. You could push a button and the pixels moved on the screen, and that was just amazing. So before I get into some of the fun projects I've been able to work on and stuff, I'm going to do a little walk through memory lane and kind of try to show some of these things that I think are really magical. And some people in this room, if you're familiar with computer science, these may be all things you're familiar with. Some of you maybe not, so I just kind of want to quickly touch on some of them and just let people see some of these things. So I'm going to talk briefly about fractals. I think it would be remiss to talk about computer science and art and not touch a little bit on fractals. I'm also going to talk a little bit about Conway's Game of Life and about diffusion limited aggregation, which is a mouthful, but basically you can use it to make pretty pictures. So an important thing to keep in mind as I talk about all these is that all these techniques are now very accessible. And so that's one thing that I want to keep coming back to in this, is how accessible a lot of this stuff is now. So memory lane here, continuing. The term fractal wasn't actually coined until the 1980s. It was coined by Mandelbrot. But a lot of the equations and things related to fractals go back much further. A lot of it really starts in kind of like the late 1800s with these things they called mathematical monsters. And there's an example over here on the right of the von Koch curve, which is one of these mathematical monsters. And it has a really simple iterative process to construct it. And a lot of these mathematical monsters, they were iterative algorithms. They were basically mathematicians describing these processes that you would repeat. And so he would basically just remove part of the line segment here and replace it with an equilateral triangle. And then in the next step, for every remaining line segment, you'd do the same thing. And you'd, in theory, keep doing that for infinity. Now, at the time, you had to do this by hand, and these things, you couldn't really visualize all of them very well. And I think it's funny that they called them mathematical monsters because they sort of saw them as these things that lived in the domain of pure mathematics that maybe had no real application in nature, hence why they were sort of monstrous, like what are these things? But I think as you'll see and what we found later, once we could start to visualize these with computers, is that in fact they're profoundly linked to nature. They're everywhere in nature. So another step on that process, there is a meteorologist, Lewis Richardson, that noticed that when trying to measure the length of the coast, that the shorter the measuring stick that he used, the longer the length he got. You can kind of imagine this like you're trying to measure this line going along the coast here, and you maybe start out with a really big yardstick, you get one length, then you're like, well, that didn't quite fit the curves, let's get a little smaller. Measure it again, it gets longer. Like, how far can you go down? You keep... So, and another surprising thing, though, he noticed about this was that if he took the log of the measuring stick and the log against the log of the total length that he measured, there did seem to be this straight line relationship. And these observations were kind of neat and kind of sat around for a while, but when Mandelbrot was looking at a lot of this stuff, he noticed those, and he picked back up on that. And he kind of formalized this relationship, and he came up with this basic equation here, which is basically relating the dimensionality of a set of points to the sort of step size or length of the measuring stick, if you will, to the total length. I won't dwell on this too long, but basically what you end up finding with this is something really interesting. If you take sort of Euclidean forms that people were used to talking about mathematically before, things like a plane, and you put it into this equation, you'll come out with 2. You're like, oh great, a plane is 2-dimensional, that makes sense. If you put in like a line, you'll come out with 1. Okay, that makes sense. But if you put in one of these mathematical monsters like the von Koch curve, you get 1.26, roughly. And so you get these fractional dimensions that are slightly higher than what they call the topological dimension, the dimension we're used to talking about. And there's something fascinating about that because it sort of fits a little bit with what we see in the thing. Like one of these lines, like a von Koch curve, for example, it seems to be something. It is technically one-dimensional, but it seems to pack an infinity of points and detail into that one dimension. So in a way, it appears to approximate something two-dimensional. And so Mandelbrot noticed this and thought that was fascinating. And so hence the term fractal he coined around things that have this attribute. So technically speaking, a fractal is just something where this fractal dimension exceeds the topological dimension. There's a much longer name for this dimension that I won't try to pronounce. And what this means visually is that when we look at these things, they tend to have self-similarity. So, you notice that with the coastline. The coastline, it's hard to tell what scale you're looking at a coastline at. You could be looking at it far away, you could be looking at it a little closer. If you're just presented with the picture and you're not told what distance this is, it's hard to gauge. Especially if you strip away features like the trees and things, if you're just looking at a raw sort of image of that coastline. And a lot of these sort of mathematical monsters and things have that same kind of property. They have this property of self-similarity where you don't know what scale you're looking at them at. And basically we find this all over nature. We find this applies to clouds, to mountains. It also applies to things that maybe aren't strictly natural, but that are sort of emerge from the behavior of many independent agents, things like the stock market. If you show people, even experienced traders, graphs of like various stock markets and indexes divorced of their labels, it's very hard for them to judge what scale you're looking at. Is this a year? Is this a day? Is this a month? You might expect that with something like the stock market that there's an overall upward trend, sure, but even like experienced stock traders have had trouble discerning that because you don't really know. There may be an upward trend for that period that you're looking at. It's stochastic, so you have that same kind of attribute there. They also have this tendency to have that infinite detail. There's a relationship between that, I think, in the self-affinity, that they seem to pack this infinite number of points in there. So I think cool thing that Mandelbrot did by formalizing these equations under the term fractal and coming up with all this is he gave us a new way to describe patterns that have always been there in nature, but that prior to that were unnameable, that we didn't know how to think about in a related way. So again, coming back to that point about art, it's really helping to enlighten us to a new aspect, a new principle of nature that we were missing before. So Mandelbrot said, clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line. So real quick here, this is just a simple implementation I did of exploring the Mandelbrot set. And you can see here that kind of self-similarity. It's not necessarily repeating itself exactly, but in general, there's this repetition as you zoom in on the curves here. Also coming back to that accessibility, this was just a little application I made for another talk I gave. This isn't anything astounding. The information for making something like this is out there. This is running in a browser. Right now it's going to render a little video so that you can kind of see, fills in the points. It shows you kind of the path we took through it. So again, I've always found stuff like this just fascinating and amazing. And one of the things that my takeaways, of the last 10 years or so is that these aren't like the domain of like people in ivory towers anymore. These aren't the domain. You don't have to be, some PhD level mathematician to do this sort of stuff. You can just do it at home with a home computer. And you can take this stuff really far. I'm going to show just briefly here this little clip from Star Trek II, 1982. So Lauren Carpenter, who went on to found Pixar, actually did one of the first uses of computer graphics in a movie. And he actually leveraged Brownian motion and a lot of these concepts from the fractal math in order to do this. So he created this generative landscape here for the Genesis. So you see these mountains emerging. And these mountains weren't something that he went in and pre-sculpted or anything. This was generative. And this was back in 1982. So I think for 1982, that's pretty astounding. And again, coming back to that, as I was just saying, one of the cool things is that this stuff is actually quite simple. It's pretty simple to wrap your head around. The power of computers is that they can apply these simple rules over and over and take them to the extreme. And because of that, you can get these emergent behaviors that can appear to be more than the sum of their parts. You get these systems that are they're informationally dense. They start with this very small seed of instructions or of information, and they produce this rich set. So another thing that we talk about in computer science that's outside of the fractals, but kind of has a lot of the same sort of properties, is you talk about, there's a concept of cellular automatons. And so I'll show you briefly here one of the most famous one that was devised in 1970 by John Conway. So some people in here may have heard of it. It's Conway's Game of Life. It's just got 4 extremely simple rules. Any cell with fewer than 2 live neighbors dies. Any cell with 2 or 3 live neighbors survives to the next turn. And any cell with more than 3 live neighbors dies. Any dead cell with exactly 3 live neighbors becomes alive, as though there was a birth on that square. So you've just got this grid, and these turns proceed. This is a game that plays itself. You just start with some random number of cells that are in a given state, alive or dead, and then you repeat these rules. And again, simple implementation I made of this. I actually did this off of a tutorial while on a plane ride. But you can see here, and I'll refresh, I think this next run is even cooler. But you see how these seemingly organic patterns and structures emerge from this, and there's no rules sort of making these overall shapes or these forms that seem to repeat and move around. The rules are all purely about the individual cells. But out of it you get these seemingly organic patterns, which again I think is just sheer wizardry, and the fact that we have these devices like right at our fingertips where you can play with this sort of thing is awesome. Sorry, I could stare at this for a long time. So, great. So the last one I'll touch on here a little bit is diffusion limited aggregation, or DLA. And this was just something I found reading a textbook and then got sucked into and played with for a long time. So I just always like to show this off. It's similar to the Conway's Game of Life in that it's a very simple rule set. I would say this is an even simpler rule set. This is just dead simple what happens here. But the result is that you get these structures that look like roots or coral reefs, like these plant-like structures. How this happens is you just seed the field, again, kind of randomly with some dots. And in each turn, you roll a dice, basically, and you say this dot moves in one of the 4 directions. It can move up, down, left, right. And they do that just randomly, kind of like a drunk person staggering around. And when they get, in this case, you can put this point in different places, but there's a predetermined sticky spot on the screen. So in the case of this black and white one here, my sticky spot is the bottom of the screen. So anytime one of these dots becomes adjacent to the bottom of the screen, like one position away, it gets stuck. And then the only other rule is that anytime one of these dots becomes adjacent to a stuck dot, it also gets stuck. So you just let them randomly wander around the screen until they get stuck. And then the result is they build into these branching patterns that look very organic. And you can kind of play with the rules a little bit. This one on the left here is one where I was screwing around with maybe they're not as sticky in all directions, or maybe they're less sticky in certain directions depending on how far up they are on the screen. You can do things like make it so that the die is slanted, basically, so that they're more likely to go one direction than another. I often tend to slant it so that they're not likely to go up, because it takes a lot longer to run the program if they can go up. But you can kind of screw around with these and produce these cool organic looking patterns. And so here's an example of it running real quick. And again, this is just stuff I just did in the browser. I did a version of this in JavaScript. I've done a version of it in Rust. It's kind of a really simple program to write. And you can see how they just kind of build up from the bottom. So like I said, I've been dabbling in this sort of stuff for a long time. I like to say I finger paint with math. None of this stuff is anything super sophisticated, but I feel like it's stuff you see more in like math textbooks than you do in a gallery, and I kind of think a lot of this stuff belongs in galleries, so I like to kind of dabble with it and see if I can convince people to let me display it somewhere. And over the past few years, I've been lucky enough to be able to do that. The first time was through the support of Run Jump Dev. They're awesome, and I believe they have an exhibit up. You should definitely go check out. I think it's at the Downtown Arts Center. It's part of this conference, so definitely go check out the Run Jump Dev folks. They're awesome. They support a lot of cool stuff in town. And also with the help of some great collaborators. I don't know if anybody in here knows Ainsley Wagner, but she's another local designer, artist, dev type person. She's since moved out west, but awesome person. And a good friend of mine, Andrew Allred. So they both really kind of helped me on this journey and got me started actually being able to present some of these. So I've now had the privilege to display 3 pieces, and also got a little, I would call it kind of an art app in the App Store. I don't know what else to call it. It's not quite a video game. It's not quite a utility. It's its own weird thing. The Fong Phone, Fongphone. I think in the Android store it has no spaces, and in the iPhone store it has 1 space. I don't remember which. Unfortunately, there was some branding miscommunication there. But so real quickly, I'll talk about a few of these things. So this first one was called Every Picture Tells a Story. I've actually got it running over there, so play with it after this if you want. But it is basically, you're presented with a screen. As you approach it, you will notice that what's on the screen is yourself, is what's in the room, being reflected back at you, generated as ASCII art, though. So in real time, it's turning what it's seeing into ASCII art. There's also a few other small things. There's some text that will kind of come through in certain spots. It sort of tries to determine where there's people based on a few simple rules, and fills in fragments from novels and stuff into there, so that potentially you generate a little bit of a arbitrary story out of it. Things that I really liked about this, and that I've tried to kind of, I feel like I half accidentally stumbled onto this, but I now try to make this a theme, is that so it's interactive. You're instantly realize, like I was saying, the magic of knowing that you're changing what's on the screen, but it's also intuitively interactive. There's no keyboard, there's no mouse. Like, I feel like those sorts of things in interactive art exhibits kind of like create a barrier, in a way. So I like that it's something that you just walk up to and you instantly know that it's responding to you, but you don't always quite know how, And that's kind of what I like. What I want to go for is things that are clearly interacting with you, but it's not always clear exactly how, but that are really just simple rules and simple things. Again, like with the ASCII art, very simple, old school kind of display. I like that sort of thing. I like keeping it minimal, for both aesthetic reasons and also, as I'll touch on in a little bit, maybe some practical reasons as well. So the next one was actually, this was a project that Ainsley Wagner conceived of here, call and response, I mentioned earlier. So this was her idea, and she came to me and Andrew, and I thought it was just amazing, and kind of instantly connected with it, and it had a lot of those same properties of the Every Picture Tells a Story. In this case, you're interacting with sound rather than the camera, but you come up to it, and what you first see is just a sea of tiny dots that are just sort of not doing much. But if you start talking around this piece, you'll notice the dots start to grow. And if anything harmonic happens, like humming or singing, you might notice that the dots start to get colors. And percussive sounds like snaps or clicks or somebody stomping their feet will change up the color scheme and kind of reset everything. So again, it's something that you can come up to. There's no controls, but you're obviously interacting with what's on the screen, and the viewer is part of it. And another fun thing about this one was pull it off, I actually got to use some of those techniques from the fractal math. So it's actually calculating that fractal dimension that we talked about earlier, an approximation of it for the fast Fourier transform of the sound that's being heard, and it's kind of using that to try to suss out if it's hearing like pattern speech or just random background noise. That's a very crude algorithm. It's not that accurate, but it's accurate enough for art. I wouldn't depend on it to go to space or something. So don't tell Chris Kimmel about it. But it's good enough for art. So let's see.
What you may be noticing is that
kind of shows it here.
As I talk, the screen is responding to me. There is a call and response, if you will. The longer I speak, the bigger these circles are going to get, till eventually, as you see, some of them pop and are repositioned. And occasionally you'll see more circles appear as this happens. Also, let's make a crude attempt at singing. I'll spare you the racket, but as you see, you start to get more colors that way. And percussive sounds
the change there
are going to trigger that background.
Which in my demo
change
didn't
itself.
seem to work in all the cases. So there's a little bit over there too. That's it, running in the gallery. And that's Ainsley there.
So what were the parameters for that? I mean, time, volume?
Which parameters?
For your demo right there. So singing is continuous, talking is got lots of space in it.
Yeah, and it's been a while since I put this together, so I'm forgetting exactly all of what it drove on. But the main metric was taking the time domain data and also a fast Fourier transform of that, and then extracting that fractal dimension, which gives you an idea of how rough or smooth that curve is, and then just kind of experimentally looking at sound samples and going, well, it looks like background noise is really rough, so let's just say anything that's that's too rough, that's approaching too high of a number here, let's throw that out. But when people talk, it looks like it's kind of between these numbers. It was a lot of just trial and error, and eventually I got something that worked well enough that you could kind of feel like it was doing that. I imagine you could get way more sophisticated, and then if you really wanted to try to do this, there's other things that might be better to look at. But I just, again, with textbooks, I had read in a textbook that you could analyze the fractal dimension of sound and that you could discern some things like this. So I was like, well, let's try it.
Okay, thanks.
Yeah. And so there's a picture of the Fong phone there. But another gallery exhibit I did was called the Fong-tron, which took the Fong phone app that I had made and expanded it to be a multi-user experience. So this one does have more of a concept of controls than the others. There are like touch devices, and basically there's a television up, and it's presenting these dots that you can move around that I was calling Fongs, and they're going to affect like a generative soundscape that's happening. And I had it so that you could connect any phone to it, but again, I want to lower the bar of entry as much as possible, so I wound up just cobbling together some touch devices that I could leave there and let people pick up that were already connected. I think that's a lot more likely to get people to interact with it than if they have to pull out their phone and scan a QR code. And so here's a brief clip of that in motion here. So coming back to what I was just talking about with the sort of the providing the tablets and things, I'll also touch a little bit on like some of the unique challenges I've found with doing interactive art. And a lot of them end up tying back to a lot of the same things that we deal with as software engineers making enterprise software. Basically, people are unpredictable. You never know how you're going to use your software or your art, especially since this is art that people touch. So you're really, by putting it out here, and by showing that you can interact with it, you're inviting people to interact with it and touch it. You don't always know how far they're going to take that. Software itself is unpredictable. sometimes something that works really well on one machine doesn't work on another machine. Sometimes something that works really well for 5 minutes doesn't work when it runs for 2 days. So you have all those sorts of problems converging of the unpredictability of your software and the unpredictability of the people using it. Also, there's the issue of you're leaving expensive equipment in a public space. That's something you don't necessarily think about at first when you're planning this and making it on your computer, and then you get accepted to present it somewhere. It's like, oh, wait, crap. Do I want to leave my MacBook in this gallery overnight for a month? Like, So I think there's some take away some things that can kind of mitigate some of those problems. And again, a lot of them are these same rules we practice as software engineers. Biggest thing is test early and test often. And maybe test on a multitude of equipment, though in the context of these gallery exhibits, what I think is best is to kind of limit some of that variability by picking some hardware that you're going to use and then testing early and often on that hardware and sticking to that, trying to make it more of an appliance. So trying to control the hardware you're going to use, which is why I carted in my own television and my own laptop over there. Like they were like, we've got a TV in here. I was like, yeah, it might work on that, but and you got to think about like kind of uptime. So test it, leave it running in your living room for a week if you can, or for at least a day. See what happens to it, and then think about disaster recovery. So like, what's going to happen if it does break and it's at a gallery and you're not there? Can you make it easy for like whoever's running this gallery to restart the software? So I tend to try to make my things such that they're on a machine by themselves, nothing else on it. If you boot the machine, it goes straight into it. So hopefully, if something goes wrong, all it is just turn it off and on again. And then beyond that, like even if that fails, I try to make a fallback link with a README, like something on the desktop. Well, if that doesn't work, click this. I try to harden it down as much as possible. Another thing is, that we talk about in software engineering all the time these days is microprocesses. So I tend to split off some of the functionalities of my app. So that one over there, there is a capability where you can hook a button up to it and press it, and it kind of tweets a snapshot of it. But that's less crucial to the functionality, so that kind of runs in its own side process. And if that crashes, which has happened because of bad internet connectivity, then it doesn't affect the rest of the display. Everything else still works. And I also tend to have a background process running that kind of monitors the health of the other processes and is able to restart and repair them. So it's not always the most fun part about making one of these things, but it's all stuff that you kind of have to consider and think about before you put it up and let it just go. I'm a walking commercial for Linux, I know, but use Linux. I mean, you don't have to. You can really use whatever works for you, but I've found that it's so much easier to control. Everybody's had that experience of running Windows 10 and it just decides it's going to update and reboot and you can't do anything about it. Macs are a little better, but even there, they don't really want you to tweak everything. Whereas with Linux, you can kind of really make this thing an appliance. You can take everything off of it you don't need. You can say, just boot, just run this one program. This is all you're good for. Just do this thing. So I think that's great. And other things you can do, and this, you don't always have so much this in like traditional software, but it's an interesting thing about these gallery things is because it is a bit of a magic trick. So make your task easier by controlling your environment. Again, with the controlling hardware, like the call and response would be a lot harder if it had to work with any microphone, but it really didn't. It only had to work with a microphone. And then there's sort of questions like, well, like with that, it works a lot better in certain lighting conditions. So if you can get it put in the gallery where it has the right lighting conditions, then you don't have to worry about tweaking that so much. All these little factors. Also trying to hide your equipment. That's another big challenge. So if you can control some of that, if you can control what it's displayed on and know ahead of time what that's going to be, then you can try to hide the computers, make them not accessible, make sure people can't just control escape, and get out of the application. And actually, I brought. This might be another slide jumping ahead, but there's a lot of cool little things like this that can help you. So this was like a single button that I made for that Twitter functionality, and what that lets you do is not have an ugly keyboard out, but also not have a keyboard out because people can mess with it. So by having this, you've restricted the inputs. They can only press one button, and it's the button you want them to press. So one thing I want to keep coming back to is that we can all be wizards now. We can all finger paint with math. All this cool, like, sci-fi stuff that was around in, like, the 70s and 80s that we thought was so cool, but now we just take for granted because it's all around us. Well, it's all around you, and it's never been easier to get started. Between 1990 and 2010, off-the-shelf CPUs have become faster by a factor of approximately 5,000. In addition, thanks to the gaming industry, there are powerful GPUs all over. That industry has basically subsidized the development of these really cost-effective, high-end GPUs. And they're doing that, so that people could play games with better graphics, but it turns out they have all sorts of other applications because the math that they're doing for that is also very useful for machine learning and really anything where you have these, you need to take dot products of matrices and stuff like that, and that's so many things. And then in 2007, NVIDIA launched the CUDA project, which basically tried to really improve and develop a better API around interacting with their GPUs. And what that's meant is that basically there's been an explosion of like open source libraries and tools that take advantage of these GPUs. So there's just so much, in addition to all the hardware that's now available, there's so much software that's available for you to build on and play with, and software libraries. So, one that's been around a long time that's something to check out if you haven't is OpenCV. That's really great for anytime you want to do a project with like kind of image recognition or image processing. It's got so many utilities in there for getting images off of cameras and doing pre-processing on them and transforming them. There's also right now, Keras and TensorFlow are becoming all the hotness. Those are machine learning libraries, and they're really amazing. And it's like back, I took an AI course back in college, and just even, in the last, I don't know however long it's been, that was like 2004 or something, it's so much easier now. So much easier to get started with thanks to these libraries and thanks to the availability of these GPUs and things. And the HTML5 revolution, I think like a lot of the stuff I've done has all been using web-based technologies. I think a lot of those are easier for people to get up and get running and started with, like JavaScript and things like that. And those sorts of technologies used to be kind of limited in what you could do with them, but like post HTML5, like suddenly now you can access like a web audio API, which is really powerful and has low-level access to the computer's audio capabilities in JavaScript. You can access things with the GPU. There's all sorts of powerful stuff you can do just inside a browser, and that lets you make things that are very portable, very accessible. And there's awesome stuff out there, awesome applications like Blender, which if you haven't checked out, I really recommend. That's open source 3D rendering technology. It's been around quite a while. It's been gaining a lot of traction lately in Hollywood. It's professional grade, like replacement for something like Maya or 3D Studio Max, and you can produce really high-end stills with it. You can produce high-end 3D movies if you have that kind of time, and you can script it so you can use it to like play around with any kind of thing where you might want to algorithmically generate stuff in 3D space. So that's a really cool thing to look at. And then in addition to the hardware and the software being more available, I think the information about how to use all this stuff is more available than it's ever been. There's so many great blogs and YouTube videos out there that really distill this information down and make it understandable for the everyday person. And this is probably, I guess this isn't new, but I feel like it's an underutilized resource. I've mentioned textbooks a couple times. Used textbooks are dirt cheap. As soon as they're no longer the current volume, or even when they are the current volume, but as soon as they're used, they just instantly devalue. So you can pick these things up on Amazon or at half-price books. I like to go and Google like what is the textbook they use at MIT for their chaos theory class or their fractal class, and then you just go pick that thing up for like $5-10 on Amazon, and it's full of fun stuff to play with if you want to finger paint with math. You don't have to understand all of it. You just have to understand enough to make cool pictures with it. It's usually what I'm going for. Back to the hardware, I'll just throw out some things. Some people in here may already know about most of these things, but I'll just go through them in case you're interested in getting started with some of this stuff. Really useful things. This guy is powered by a Teensy, And I don't know if you saw, I think his name was Troy yesterday, that did the talk on keyboard hacking. He had one of these around his neck, which I thought was great because for this slide I couldn't remember what it was called. And all morning I was trying to figure out what this thing was called, and then I got to the conference and there was a guy with one hanging on his neck. I was like, that's the thing, the teensy. But these are really cool because they let you plug into a computer and it's instantly recognized as like a USB keyboard or mouse, and then you can pre-program it to do different things. So like in this case, it's programmed to, when I press this button, send a keystroke. Sounds simple, but I had a lot of trouble doing that with like an Arduino. This made it a lot easier, and this now opens up the possibility like you can create custom interfaces that to your application just look like a normal keyboard, so you don't have to do anything complicated with your program, and you can test it with a keyboard. But when you put it in the gallery, you can throw up your own little custom interface. And of course, like the Raspberry Pi, which more and more people are familiar with. This is one here. It's just a little credit card sized computer. You can pick these up for like $35. They keep coming out with new versions of them that are faster and better. And you can put Linux on there, and you can use it to power stuff. And so coming back to my appeal, I mentioned that there was another reason why I like to keep things simple. Well, you know, it sucks to leave like your latest and greatest hardware in a gallery. So if you can make something that's really cool, but that is just building on these things that have been around since like the 70s, they don't necessarily need the most powerful computer to run them. So an old laptop you have laying around, maybe even a Raspberry Pi, can possibly power one of these things. I will say I've had limited luck getting a Raspberry Pi to really power one of these galleries. Usually it's just slightly too slow to keep up with what I want, and an old laptop works better. Each one gets better. They are great for like being components in a lot of these things. Like they're great things to sort of power. I had one that was powering like an auxiliary display with like information about the event and stuff you could click through. So they're great for that sort of thing. I use them all over my house for various tasks. But those are out there. Arduinos, which are even cheaper but a little less powerful, they're out there. They're great for components of stuff like this. You can hook massive, there's so many sensors out there that you can hook into an Arduino, and then you can sense the environment and you can react to it. So it's a great thing to have. There's a website called Adafruit that has sells tons of these things and has lots of information on them. And if you haven't already and you're interested in getting started with this, like I'd say learn virtually any programming language. Doesn't really matter which one. I think people just getting started get stuck on like, which one do I learn? If you're just getting started, it doesn't matter very much if it's a language you've heard of. It's probably worth learning, and it can probably do what you want. Technically, any of these languages can do anything. The only thing I would say is maybe look at the thing that you want to do, the thing you want to accomplish, and then look at what people are using there, because a lot of times there's an ecosystem around a programming language, and so depending on what that ecosystem looks like, what the culture looks like, there'll be more people doing the sorts of things that you want to do in that language than others. So while you could use any language, it'll be easier for you to find libraries that help you. It'll be easier for you to find people on the internet that have written sample code. If you sort of pick one that people are using to do the thing you want to do. But you don't have to. You can really just pick any of them. Learn JavaScript, Python, C#, C++, whatever. They're all fun. They'll all get stuff done. And like I said, just build on the shoulders of giants. Look for open source libraries and projects that can help, and run with them and play with the tools that are out there. So really what I hope everybody takes away from this is that, we can all be wizards. Don your caps, get out there, make cool stuff. Maybe go check out the hackathon. I mentioned earlier that I work with Sonotype. I think we've got some swag floating around the hackathon. So definitely go over there and check that out and make some cool stuff.
I have a question.
Yeah.
I had questions. The audio, recognizes Pierce audio, you had the bubbles.
Yeah.
You had callers. The callers were aesthetically pleasing, or it seemed to be. Was that a palette predetermined?
Yeah, the palettes were predetermined. There was a handful of predetermined palettes, and but Ainsley probably contributed the most to that sort of thing. She has a design background, so.
I was just curious if you pick one color and generate.
So
use the color.
yeah, and I'd love to do that. I always struggle with that, finding the right balance between like predetermining things and like letting them generate, because you want it to be pretty, or at least I usually do. And like a lot of my attempts at like making everything sort of generative ends up in stuff that's ugly. So it's hard to strike that balance between like sort of predetermining something that's going to be pretty and like also letting it be something that's always unique and generated on the fly.
Do you know if the interactive art community is like processing.org or frameworks?
Processing. When I first started playing around with this stuff, I used processing a lot. I don't know if it's as used as it used to be. I think it used to be used a lot. I feel like it was originally tied to Java, and then as Java sort of got less cool, it seemed like it took a hit. And there's some other frameworks that have kind of like come up. It is still around though. I know it's no longer strictly tied to Java. You can render it to JavaScript and stuff now too. That's a really cool one. I've been kind of doing most of this stuff more from scratch these days, because for me that's part of the fun. And I guess that's a whole other aspect of this that we didn't even get into, but it's like, is code itself art? And I don't know, I didn't want to dare tackle that, but that's its whole another topic. For me, it's at least part of the craft, so I kind of like to, I'll leverage libraries and things, but I like to go as low level as I can, because I feel that that's part of the craft.
Have you played with any existing, what I'll call kiddie frameworks like Scratch?
Well, I think that's kind of what you were talking about with like processing, although it's maybe, so I haven't played with Scratch. Processing's a little more advanced than Scratch, but yeah, I've definitely played with processing. I haven't played with Scratch. I'm familiar with it. It's great because Scratch, I think, still comes on like the Raspberry Pi. If you get their base installation and install that fresh, it comes with Scratch, because it was really created as an education tool, but it's found all sorts of uses in industry and things like this. And
yeah, well, I mean, the future is, for this is to get kids to do it.
Yeah, I think it's kind of fascinating. I feel like the companies actually struggle to walk that line, because they really want to be an education company, so that's their main focus, but they're actually getting a ton of money from the industry who's actually using these things in real products. And so I feel like they're constantly kind of pushing back against a lot of their customers who are asking for more enterprising type features, and they're going like, whoa, these are supposed to be for schools. We didn't know you were going to put it in a satellite, like, come on.
So I was curious about what you're using the Raspberry Pis around the house.
I had one that is still kind of going, but I need to update this project some, but it was collecting data from sensors and graphing it, so like collecting like temperatures of different rooms or outdoors, and you can detect humidity sensors. There's this openenergy.org kind of framework that you can build out. They sell like ready-made appliances, but they also have like details for how to kind of make your own with a Pi.
You just looking to like use that data to improve your house?
Yeah, it was just kind of a fun project. I'd like to kind of use it to kind of track like humidity is the next thing I want to really look at to see, because we don't tend to run our AC and heat that much, which causes humidity problems.
Gotcha.
Because most houses are built assuming that you're going to just run that all the time. So I want to kind of get a sense of like how bad we're damaging the house when it gets really humid and stuff like that.
I see. Okay.
Also for gardening experiments, like we've experimented with like we've got raised beds, and we've experimented with different types of covers for them, like for overwintering and stuff, like to get a sense of what's going on out there. Other thing is Nextcloud, which is a cool thing for like syncing. You can sync files to your phone or across laptops. I use that for all my notes, and so it's kind of like Dropbox, but you can just run it on your local network if you want. And so I use that a lot. That's running on a Pi. Retro gaming, I've got one that's got all the old retro games on it. Stickers. Anybody want stickers?
I like that they go to
Thank you.
Sonotype.
What's that? Oh yeah, Iron Maven. Yeah, this is Sonotype.
Oh, Iron Maven.
Yeah, it's not Iron
Maven.
Maiden.
Iron Maiden.
Yeah.
Sonotype was just like, we really like Iron.
Yeah, it's Iron Maven.